Very good. All right. Well, thank you so much for joining us tonight. It is the virtual Cranbrook meeting, the June meeting of the Warren Astronomical Society. It's been 3 long months since we entered lockdown. Well, Michigan is going to be phasing into quote-unquote normal business operations circa June 8th. The board of the Warren Astronomical Society is committed to keeping all of us safe. So we will be phasing out the virtual meetings when we and our host institutions of Cranbrook, Macomb, and the Metro Parks find it feasible to do so, which is not today. So thank you very much for joining us via WebEx and or YouTube. I would like to, at this time, since we're not doing the roll call, go right into In the News in the Sky. And the presenter for tonight is me. So let me make sure that this works. Share content, share keynote. All right, can Doug or Jonathan, I can see you. Can you give me a thumbs up if you can actually see the screen? Very good. Okay. In the news, Bob and Doug have gone into space. After a 2-day weather delay caused by Tropical Storm Berta, Bob and Doug successfully lifted off from historic Launch Complex 39A on Saturday, marking the first human spaceflight from American soil since the last launch of the space shuttle back in July of 2011. Of course, I didn't mean that Bob and Doug. Here are the real Bob and Doug, Commander Doug Hurley and Joint Operations Commander Bob Benkin, veterans of the Space Shuttle program. Here they are in the crew capsule of the Endeavour with their toy Apatosaurus mascot for the mission. In addition to being a return to human spaceflight without an assist from Russia, this marks the first time a commercial operation has put human beings in orbit. And here is a picture of the splendid launch of the Falcon 9 rocket from, again, historic Launch Complex 39A. The Crew Dragon successfully docked with the Harmony module. What?
We weren't seeing the rocket, and we're just seeing the rocket now.
Okay. Okay, good to know there's a leg. Yeah, so this is from the live feed that many of us watched on Saturday. Crew Dragon successfully docked with the Harmony module of the ISS on May 31st. That was yesterday. The first stage of that Falcon rocket successfully returned to the SpaceX barge and was recovered. In the meantime, Doug and Bob have been welcomed by their colleagues in the ISS, where they are joining Expedition 63. The Dragon capsule shown here will remain docked until approximately 1 month before the next Crew Dragon's scheduled arrival on its first full mission, which is to bring not 2, but 4 astronauts, 3 of them from NASA, 1 of them from the Japanese space agency JAXA, on board. So I believe many of us watched it live. It was a great historic event. For those of us who've been, skeptical of some of the Elon Musk ventures, well, it worked. And how? Not everything is going great for SpaceX, though. This conflagration is from the live feed of the testing of the 4th prototype SpaceX Starship SN4, which underwent what is technically called a rapid unscheduled disassembly following a static fire test at the Texas facility. The Raptor engine fired nominally for a couple of seconds at 1:47 p.m. local time and then shut down. There was some kind of uncontrolled gaseous leak, and 1 minute later, this happened. Definitely rapid disassembly there. All right, we have been bemoaning the lack of sunspots, lack of activity, lack of everything on the sun. We've been fending off conspiracy theories from social media about an incoming ice age, which no. But after 3 years of effectively napping, the sun may be waking up and the sun may be cranky. On Thursday, May 28th, it emitted the largest solar flare since 2017, indicating that our star may be coming out of a quiet period that's lasted for several long years. Though the flare erupted on the side opposite Earth, the Solar Dynamics Observatory could detect its glow above the solar surface, and that is visible in the upper left corner of this image. So we may be in for sunspots and other fun things to enjoy in our solar scopes. All right. A Census of Baryons may sound like a title of a bad fantasy novel, but it may be the answer to a long-standing cosmological mystery, specifically the whereabouts of about half the estimated ordinary matter in the universe. 5% of the universe is estimated to be ordinary matter, protons, neutrons, electrons, the stuff that makes up you, me, the cat, as opposed to dark matter or dark energy, but only half of that, in turn, had ever been successfully detected. In the late 1990s, cosmologists made a prediction about how much ordinary matter there should be in the universe, about 5%. Sometimes you see it given as 4%. But the fact is, when they counted everything up with what the tools they had to measure at the time, they came up short by a lot, by about 50%. This is known as the missing baryon problem, and for over 20 years, the solution has eluded cosmologists. Well, we may have an answer. So, a 2007 hypothesis involving fast radio bursts was tantalizing. The idea was that as the fast radio burst, this incredibly powerful outburst of energy goes through the intergalactic medium, it's going to interact with the missing baryons and disperse, and we'll be able to measure it. The telescopes at circa 2007 were not sensitive enough to be able to measure the effects of a fast radio burst on baryons in intergalactic space. Thanks to newer telescopes like the Australian Square Kilometre Array Pathfinder, ASCAP, the dispersion measures of 6 FRBs have been measured by scientists at the collaborative project CRAFT, which includes scientists from the University of California, Santa Cruz, and other institutions. They were able to make a rough calculation of how much matter these radio waves pass through before reaching the Earth. And the quote from their paper: "We were overcome by both amazement and reassurance the moment we saw the data fall right on the curve predicted by the 5% estimate." Of course, as a possible solution to a long-standing conundrum in cosmology, more research is going to be needed to make sure this holds up, but this is pretty cool. That concludes my news roundup. Of course, we do have things happening every day, but that was my selection of things that we needed to know. In the sky, on June 3rd, Venus reaches inferior conjunction, meaning it passes directly between the Earth and the Sun. If we had a perfectly aligned solar system, where everything was on the same level plane, Venus would pass in front of the Sun the way that it did for us last on 2012, and we would have a transit. Since we are not perfectly aligned, we will all be dead before the next transit takes place. And Venus this time will pass by, I believe, above the Sun, unseen by us, or at least not detectable safely. Meanwhile, Mercury will hit its greatest eastern elongation on Thursday the 4th and can be seen in the constellation Gemini for about 2 hours after sunset, though it's going to be pretty low. Meanwhile, the outer planets are having some fun with us. Have you ever seen a conjunction between Pluto and Jupiter? Now's your chance. Former ninth planet is passing less than 2 degrees from the king of planets this morning of June the 1st. Tiny Pluto is presently magnitude 14.7. It's a challenge for telescopic observers under less than ideal conditions, but imaging equipment should pick it up just fine. And if the gibbous moon right now is a problem, the darkest skies later this month should allow you to see it because Pluto's not getting much brighter or much dimmer at this point. Oh, there's my misplaced picture of Mercury hanging out below Castor and Gemini on the 5th. Finally, Jupiter and Saturn are having some fun this week with M75. Early risers are going to be rewarded by a rich display of planets. This week, Jupiter and Saturn will effectively bracket the globular cluster. And meanwhile, Neptune and Mars are making their own odd couple conjunction. So in between Pluto and Jupiter, Jupiter, Saturn, and M75, Mars and Neptune, you should have some planetary fun this week, even with the moon. And that concludes In the Sky for this week. We do not yet have anybody signed up for the Macomb meeting. If you would like to join us for your own take on In the News, please reach out to me or to Dale, the first VP, and we will get you on the schedule. Okay. Any questions?
I better help.
Cool. All right. Within the news concluded, we can do the officers' reports. As your president, those of you who joined early for the board meeting got to hear me say that I'm incredibly proud of you all for continuing to meet, continuing to join us under the circumstances. I find it absolutely fabulous that we have this community going, doing our events, doing our presentations, despite not being able to physically see one another or share telescopes or do any of the things we used to do. It means a lot. And if you know, it's we're going to reopen when we safely can, working with their host institutions. We were talking at the board meeting about some of the measures that we're going to use to decide when it is safe to start phasing things back in. But in the meantime, we're glad to have you all. And reading the WASP has been a great joy, seeing the continuing activities that people are doing online. Bob Tremblay noted that, you know, he's resumed his online outreach activities. He'll talk a bit about that, but it is an honor to lead you all through this crisis, and can't thank you all enough. And with that, I will pass it over to Dale.
Thanks, Diane. Well, next month, or rather later this month on June 18, we have Mark O'Malley giving a presentation on the life and times of Werner von Braun. Then a month from now, on July the 6th, John Blum is going to moderate a debate on various aspects of sending people to Mars, at least doing it anytime soon. Arguing in favor of sending people soon are Jim Shedlowski and myself. Arguing strongly against will be Ken Burton and Bob Tremblay. So it might be a little warm of a debate. We will see. And then also on July the 6th, Diane Hall will be giving a short presentation. I'd like to tell you that we are getting soon to the point where I'm going to need additional speakers soon. Normally, I like to ask people in person at our meetings, or club members at least, but I can't do that now. So please let me know if you have a topic for late this year or early next year. Either a long presentation or a short one. I need your help. Okay, thank you.
Thank you very much, Dale. And now we'll pass it to Riyadh to give us the latest on Stargate.
Thank you, Diane. Yeah, I visited Stargate about 11 days ago to look at the buildings, make sure all the equipment, everything seems to be fine, good condition, no leaks, no problems. The dome is fine. Both buildings are okay. The only thing I noticed was we have a table inside one of the buildings, the observatory actually itself, that leans on the wall. It had maybe just fallen down. And I tried to fix that temporarily at least, but in the future I'll need to go back and work on it a little bit more. In the meantime, of course, we also continue to have maybe online open houses until the buildings will be opened at the observatory, and we will follow, or at Camp Rotary. We will follow the direction, of course, of the Metro Parks and see when that will happen. So for now, we will continue to have those open houses online and not in person. That's all I have.
Thank you very much, Riyadh. And now we'll pass it to our secretary, Glenn.
The May minutes are in the current WASP. That's all I have to report. It can be viewed there.
Short and sweet. Thank you, Glenn.
You're welcome.
And now I'll hand things over to Mark, our treasurer.
Thank you, Diane. The Treasury's been pretty quiet here lately. System has adequate liquidity. We have 82 current members, and so far this year we've taken in about $1,800, spent $510. We have $22,000 approximately in the bank. We've got some checks and cash. In addition to that, the details are in the WASP.
Thank you so much. And
Welcome.
Bob, how's virtual outreach coming along?
Oh, Bob, you're muted.
I am testing.
Now you're good.
Okay. Yeah, so that's pretty much all we got right now is virtual online. So if any of our members are doing presentations, I'll get with you, Jeff. I'd like to make sure that gets reported in the next issue of our newsletter. Last week I gave my sun presentation, and this afternoon I gave a tour of the solar system using Space Engine, similar to what I did for the WASP a couple months back, and that was pretty cool. The only thing I don't like about it is all the kids were muted, and every single time I've given that presentation, I turn all the moons of Jupiter on, everybody goes, and I miss that. I miss gas because I look for that when you're showing this stuff. Diane and I are going to be talking about astronomy at the beach. There's some issues with astronomy at the beach, which we'll be discussing. I can make minutes available. Let's see down here. There is something I got from the Solar System Ambassador Program. There is a NASA program called the NASA IPAC Teacher Archive program, and it allows teachers to do astronomical research, and applications are open until September 14th, and the program is funded completely by NASA, ADAP, and its contingent is on availability of funding anyway. It allows teacher to do actual research. I can send information to any educators who might be interested in doing some actual astronomical research. Dolores Hill on the OSIRIS-REx mission team sent me an update. We have an official target date for the asteroid sample return touch and go maneuver. It's going to be October 20th of this year. So that's very exciting, and I will be looking forward to that. Other than that, again, if anybody's doing outreach, please let me know, especially online. Solar System Ambassador Program, I registered the things I did today, and they've updated their site for reporting. I like what they've done with it, and they've added a section for online distance educating. So, sign of the times. Anyway.
Indeed. Thank you very much, Bob. And finally, we've got Jonathan with publications.
The WASP is through very little doing of mine, up. The latest issue features the debut in our pages of David Levy's column, which I encourage you to go check out right now. It also contains a second installment in Dale Teamey's Armchair Lunar Explorations, which is super fascinating, as well as amazing astrophotography contributions from Bill and from Doug, as well as the monthly Rick Hill Over the Moon installment. So lots of amazing stuff in this issue. Go read it.
Yes, lots of fabulous articles gracing our humble paper, which is just, again, opening up and reading it and seeing the talent assembled there is incredible. All right, so that concludes our officers' reports. We now do special interest. I do not think Solar Marty is with us. Has anybody seen him on the call?
He is. He's on YouTube, so I have his
He's on
report
YouTube.
here.
Very good. Let's hear it.
Yep. So an active region has just rotated into view. It was flaring a few days ago, and yesterday it did have one very small spot, but that has now disappeared. So the sun is again featureless, but watch this space. The new solar cycle seems to really be here.
Cool. All right. History subgroup. I do believe we have DL Teamy coming in from Florida.
Had to find a mute button. I don't really have a whole lot to report on the history report. I'm still digging around for some more of the Detroit Astronomical Society papers. Apart from that, there's not been a whole lot going on. I've been focusing mostly on the current WASP. I would like to encourage everybody to check out the movie review, though. That was a bit of a challenge for artistic layout matters. That's what I have for
It's
the
a very
report.
It's an uncharacteristically terse movie review.
Terse would be the word. So back to you guys from sunny Florida.
All right. Thank you, Dale. And hands-on group, Riyadh. I know there's not much to report, but let you have it.
Yeah, thank you. Yeah, still, of course, as you're saying, not much to report. But, you know, if you get a chance, we seem to have some clear skies off and on. So I do myself at least go out and take a look whenever I can. I at least take a pair of binoculars outside, take a look if you could. And yeah, we'll continue to struggle with this until such time as we can get back to our observatory.
Thank you very much, Riyadh. And likewise, discussion group is on hiatus until we can meet at somebody's house to discuss, though we may have another virtual discussion group in the event that an open house night does not look promising. Let's see. So I know we have observing reports. Gary, are you in a position to read it, or would you like me to?
See Clayton turning the microphone on.
Good.
I think Clayton is speaking, but I still do not hear anything. Still not coming through. We were having some problems with audio earlier with the number of participants.
I can give a quick.
Two things muted. Can you hear me now?
There you go. We hear you.
Yes.
Okay. Gary would like you to please read it. Thank you.
Uh-oh.
So I
Gary's at a loss for words.
while we're waiting. I was able to get out yesterday and check out Venus right at sunset. through a couple thin slivers of clarity in the clouds. And I don't know what Venus's illumination is now. I think it's somewhere around 3%. It's awfully close to the sun, but it was surprisingly easy to spot with binoculars, and I had a 70 millimeter refractor. Pretty cool to see that thin of a sliver, and the light sure seems like it goes more than 180 degrees at this point in time.
Very cool. We saw it last weekend, and it was a very small crescent, but we did not have that. Did not have as much illumination as we expected from its cloud bank. All right. Well, if I'm not Gary, Clayton, can you give us a thumbs up if you're able to do the reading? Otherwise, I can do it.
Clayton said Gary would like you to do it.
Okay, I could not hear him. Okay, 31 May. Sky extremely transparent, but seeing fair. Bean Observatory. 5-inch long focus Newtonian, approximately 100 times magnification. Both equatorial belts are of equal intensity and width. This is Jupiter, of course. Very usual, however, hint of yellow in the south equatorial belt, a well-delineated south temperate belt evident, no analog in northern hemisphere, no features in the equatorial zone. This observation of Jupiter from GMRS is followed by the explanatory note, whereas, whilst those who own a space-age programmable telescope with a host of extras dream of yet another upgrade, a home-built reflector on a plumbing pipe mount and homemade wooden tripod with hand-me-down eyepieces equipped with a mirror polished and figured by a teenaged Gerald Christopher Persha, forges ahead. Good job, Gary. Good job, Telescope. Okay. Bill, your sound is on, so I take it you have an update from the CW Sirius Observatory.
Well, actually, not much has been going on as far as astrophotography the past couple of weeks. I bought a new wave runner, so I've been playing with that. But regardless, I was working with Ken Lord, and I think Ken is online on how to mount his DSLR camera on his mount. I hope that worked out well. I haven't heard back from him if he had a chance to use it or anything. But in the meantime, if anybody else has any questions, this is my email address. Is that coming in straight, Diane?
Yep. Yes.
Okay, that's my email address. If anybody has any questions, concerns about astrophotography, just email me and we'll go over them. Thanks.
Hold it up higher.
Okay.
Yeah, thank you.
How's that, Dale?
Good.
So, Bill, a couple weeks back, I got my first, I'll call it decent DSLR astro photo up north. I used a piece of like 1x2 to attach it to my equatorial mount, and I had just a standard telephoto kit lens set to about 250 millimeters focal length, and got a decent picture. I was pretty excited when I saw how green the dumbbell nebula showed up, and then I was able to capture a few small, well, they look small in the photo anyways, but a couple galaxies. Pretty cool.
Good.
I think I might be hooked.
Perfect. I'm telling you what, it only gets better from there. So yeah, if you have any other questions or anything, just email me and we can go over them.
Cool, will do.
All right. That's it for me, Diane.
Thank you very much, Bill. Okay, we are a bit ahead of the game. Do we have any additional observing reports or anything else like that?
Well, we had an observing report. We were up north this last weekend, and not this last weekend, but the weekend before, and we did not have quite the great skies that I had the previous week that I was up, but we were still able to catch the sliver of a crescent Venus, which was really impressive through binoculars. We were actually able to do a considerable amount of galaxy observing through hazy clouds, which gives you an idea of how dark it is up there. So Meanwhile, I'm also very interested in getting more people observing up in the Alcona Sunrise Side area. So watch this space. There will be an announcement eventually.
Very good. We also
You're still
have
muted,
seen multiple.
Diane.
No, I'm not.
No, you're good.
We have
Jonathan, where
also
is
had
that? I'm sorry. Easy to step on people
is-
here, but
It's right
Okay.
here.
yeah, nice, nice, good spot.
We also have seen multiple passes of the ISS, including a pass last night when the Crew Dragon was attached to it. So it was a very
Cool.
nice high pass, 61 degrees up, very cool. So the ISS has put on quite a show lately. All right, any other observing reports before I pass the baton to Dale Parton for the short talk? All right, keep looking up, people. Dale, I would now like to turn things over to you.
Okay, am I on? Can you hear me?
Yes.
You are?
Okay. Well, our first speaker tonight will give our short presentation is our treasurer, Mark Jakubisin. Mark, I'm so glad you took that job. Having
You're
done
welcome.
it before myself. He tells me that he enjoys very much observing with Warren Club members. Hopefully we can start doing that again soon. And also observing from his backyard in Chesterfield, Michigan. Tonight, he will discuss the impact the atmosphere has on light waves as they travel from outer space through a telescope and all the way into our eyes. We'll also review some things you can do to optimize your observing experience and get the most out of your equipment and local environment, something we all want to learn how to do. Mark, you're on.
Okay, and I got to turn my mute off. My mute off? Can you guys hear me?
Yeah, you're good now.
Okay, thanks, Diane, because I hit screen share before I turned the mute off, and it disappeared on me. So let me go into presentation mode here. Okay, so the title of my talk is Seeing is Believing. And I like this photo here because it kind of shows what happens to the light as it passes through our atmosphere, because the atmosphere is a fluid after all. And just a little background, some fundamentals. Incoming light from deep space is, for the most part, they're plane waves, at least as far as we could measure. And as they enter, much like a lens, you can see when the plane strikes the leading edge of the lens, the speed of light changes as light passes from a vacuum into a different medium. And as that speed slows down, the rest of the wave continues on at the same speed, which kind of more or less stretches and curves the wave, and that's more or less how a lens works. So the speed of light changes as it passes from one medium to another. Warm air is less dense than cold air, and the index of refraction changes with the density of air. So think about a mirage and the effects that a mirage has on light. Layers of air, turbulent air masses, can be thought of as ever-changing lenses, constantly inducing small distortions in the wavefront of light as it passes through the atmosphere. So I found this a number of years ago, kind of studying up on this, but I found this video here, which I'm going to have to jump out of presentation mode, and hopefully this will show up on your screen. But this is a technique. It's called Schlieren optics. It's kind of almost like a Foucault, like a knife edge test, where you're using a long focal length mirror and a knife edge and a light source to magnify the effects of atmospheric refraction. And this video here, hopefully you guys can see this and let me know if it actually plays or if it's really choppy. But you could see what happens as the light is passing through different densities of air. You can see the lensing effect of the light as it makes its way back to, in this case, the camera. It makes it very obvious the effects of light, the effects of the disruption of the wavelengths of light. So here's kind of a hair dryer. I think it's kind of neat to see. Really shows what's happening in a visual way. And there was another video here. And I thought this was apropos considering the pandemic, but this is just showing a couple people in normal conversation. And you could see the different pockets of air and the different densities of air as the light passes through them. I'll pause this, go back to my presentation. Did that video show up okay?
Yeah, it looked great.
Okay, good. All right, so I'll go back into presentation mode. So the same thing is happening. The light waves as they pass from the outer space and through our own atmosphere, which we unfortunately have to breathe. Light waves pass through the atmosphere for the most part with very little interaction and heat transfer to the gas. But as that light strikes objects on the Earth, different objects have different absorption levels and masses. And the bottom line is that radiant energy strikes those objects, and through conduction, generates heat, which results in convection currents. And you've got surface tension within the air, which causes it more or less to the air to rise in a chaotic fashion, like similar to a lava lamp is the way I like to think of it. So you've got a lot of local convection and atmospheric conditions taking place. And as that warm air rises, it's running into prevailing winds and it's getting mixed and stirred about. So in my graphic here, you can see we've got plane waves coming from space. And as they start interacting with those roiling, chaotic fluids in the atmosphere, it starts to distort the wavefront of light so that it's no longer planar, coming to us in somewhat of a scrambled fashion. And on good days, it comes to us pretty much in, I'll say intact, but in close enough that we can image and get good detailed views from space. Moving on to the next slide. So in this slide, I'm just talking about a little bit about geography. And typically, very good seeing locations are where you have laminar airflow, where you don't have a lot of disruption. And oceans, large bodies of water, are good places where you don't have a lot of differential heating and cooling going on. You have more steady temperatures, and you tend to get more laminar airflow as that air makes landfall. If it's coming from offshore, you do get some turbulence as it comes across land, but at nighttime, that turbulence tends to subside pretty quick. So if you live near the ocean or near a large body of water, and you have offshore winds, my first smiley face here, you're going to have a pretty good location for good seeing conditions. If you live on a mountain or at a higher elevation offshore, which is even better yet, you get the added benefit of better clarity, less atmosphere to look through, and laminar airflow. If you're going to build your retirement dream home and you're wealthy and you have the choice, you might want to think twice about building a house or relocating on the leeward side or the downwind side of any large landmasses like mountains, right? Because it trips up the air and causes all kinds of turbulence, and you're gonna constantly struggle with seeing. In addition to the heating and cooling effects that you get off of the mountains themselves. So how does seeing affect astronomical observation? So in my experience, seeing is critical for all types of viewing, especially when using larger apertures. Close double stars, double stars with significant differences in magnitude or even color. They just don't, you can't resolve them without good seeing. Planets, which I'm especially fond of observing, and the moon, it's a whole different ballgame when you've got excellent seeing versus lousy seeing. And a lousy seeing day, even a 60 mm refractor can some degree be limited by seeing, never mind an 11-inch or a large aperture telescope. So there's a number of seeing scales that are used to quantify the effects of seeing. Antionati, you've got a scale 1 to 5, 1 being excellent, 5 being bad. Pickering is a scale 1 to 10. These were developed early in 1900s, if I'm correct. And the Pickering scale, you've got a scale 1 to 10, 10 being excellent. There's an astro imager out there who I particularly admire his work, Damian Peach. He came up with his own scale. Bottom line is that you've got gradations between really lousy, unstable seeing and excellent seeing. Astro imagers like to use FWHM, full width at half maximum, which is a way of determining it's kind of the relationship between the signal strength and angular resolution, like a point spread function. But I've got a couple links here I'd like to share again. And one is from Damian Peach showing images of Jupiter going from really lousy to excellent seeing. And then he's also got a very nice demonstration of the effects of seeing on stars and what stars look like through a telescope. So switch back here again, browser. So here's an example of very poor seeing. And you can see it's more or less, people call it looks like a flag flying on a flagpole. There's very little detail that you can discern. The whole image is wobbling around. Not very enjoyable to look at. So this is an example of mediocre seeing, or very good seeing. And this is common, I would say, this level of seeing in our location here near the 45th parallel in Michigan. Not too bad. You spend a lot of time and you're a patient observer, you get to pick up quite a bit of detail over a period of time. And then this is an example of what he considers. Okay, so here's some examples of stellar observations, and then this is a Pickering rating number 1, very poor. You can see it's just very scintillating, not very appealing to look at, right? And as we progress down, a 2, Pickering 3, Pickering 4, you're kind of starting to see a little bit of an airy disk pattern. 5, 6, and as we progress, we started getting into the excellent seeing conditions. You could start to see a steady diffraction ring. And this is the kind of seeing you need if you want to split close double stars in the sub-arc second, sub-half arc second range. You really need to have that excellent seeing. Or if you're looking at unequal doubles where the second star falls within that first diffraction ring, you really need a good steady sky to do that. Okay, sorry. Go back to the presentation. Okay, so moving on, talk about the air inside of your telescope, because not only do you have to contend with the air from the stratosphere all the way down to your optical tube, but once the light waves enter your optical tube, there's still potential for them to be disrupted. Two currents, one thing that happens quite frequently. And one type or one way they're started is by the differential heating and cooling of the outside of your telescope. Portion of your scope, the top side, is exposed to the blackness of space. It radiates heat, cools very efficiently. Where the bottom half of your telescope is exposed to the ground, or any objects that you're set up around, and is actually absorbing some of the radiation from the heat that's stored in the ground. And that causes a differential in temperature in the outer tube of the scope, which will set up convection currents within your telescope itself. There's actually, in some cases, you get supercooling where the thin wall of the metal tube, if you got an aluminum tube, will drop way below ambient temperature. And it's very obvious when that occurs because you end up with frost or dew on the top of your telescope, and the bottom can be completely dry. The other factor is mirrors and lenses that have mass, they retain heat. They're not properly cooled. You get boundary layers that are created adjacent to any air glass surface, and that warm air tries to climb the mirror or lens, and it can definitely have a big effect on your the quality of the image that you're looking at. If you defocus, one of the telltale signs, if you defocus a star quite a bit, you'll see what looks like worms wiggling or writhing across the image. In compound telescopes, like a Schmidt-Cassegrain, the baffle tube, center baffle tube, can create like a smokestack effect. And again, in a defocused star, will create a very obvious pattern, looks like a chimney. So all those effects add up to degrade the image. It's just kind of a diagram of what's going on with tube currents, where you've got the rising air and warmer air along the bottom of this tube, and supercooled or cold air at the top circulating. And one of the ways you can mitigate that is by using mixing fans, or in some cases insulating the optical tube is reported to provide significant benefit. So just going through real quickly different telescope designs and some of the drawbacks and benefits to each as far as inside the optical tube seeing, if you will. Refractors, one of the big benefits of a refractor is the light only passes through the optical tube one time. They tend to be smaller, so they tend to reach and maintain thermal equilibrium easier than larger telescopes. And just the fact that there's no obstruction, you've got more of the light energy concentrated within the center of the airy disk, as opposed to being in diffraction rings, which just makes it a little bit more aesthetically anyways appealing. Reflectors, you've got a double light pass, so the light's passing through once to strike the mirror and then going back a second time to the secondary. The open design exposes the mirror to air for faster cooling, which can be somewhat of a double-edged sword, because just the smallest amount of delta T, difference between the mirror and the outside air, will set up pesky boundary layers. Once again, can be mitigated by fans to strip away that boundary layer. And then lastly is the observer's own body heat. If you think back to the Schlerin images, your own body is constantly giving off heat, and depending on which way the wind's blowing, that can pass it right in front of the optical tube and cause problems. The catadioptric, probably the most troubled of the designs, because you've got three passes of light. You've got the initial pass to go to the primary, goes back to the secondary, and then a third time back through the baffle tube and into your eyes. And then here's just a little diagram I created to show what a heat plume looks like coming off of a baffle tube, and that's what it would look at an image of a defocused star inside and outside of focus. So real quick, I'll just run through some things I look at to try to predict, to make sure I get out there on those days when the seeing is most promising. One site I like to look at is called earth.nullschool.net. It's using weather balloon data from all over the place and crunching it through a supercomputer and basically creating a simulation. You can go in here once you go into the website, and if we have time, I'll run through it. But you set the mode to air. You set the height to 250 hectopascals, which is the height of the jet stream. Overlay set the wind, and you can use these little carrots here to go forward 3 hours at a time or days at a time for the prediction. And you could see the location of the jet stream, because the jet stream is one of the big factors for poor seeing, especially when it's all broken up like this. And it has a tendency to linger over Michigan. We're in a really great spot, being halfway between the equator and the North Pole for the jet stream, and lots of turbulence, unfortunately. Just on an obstructed view here, this was on 525, not a guarantee of good seeing, but it's good when the jet stream runs north like that and we have high pressure that lingers. And just a couple tags to show locations of some of the prominent observatories. You got Mount Wilson right offshore on the west coast, good laminar airflow, same thing with Chile. The second site I look at is Clear Dark Sky. This is linked to in our Warren Astronomical Society homepage under Stargate observing and the weather report. You want to focus in on seeing here, and you've got the color-coded scale. You can see our seeing was pretty lousy when I took this snapshot, but this is the time of day. And what you're looking for is large blocks of dark blue for a good seeing forecast. And just as a comparison contrast, Dale, this is probably something you're more used to seeing, but this is a view of the seeing down in the Keys. Nice long block of dark, good seeing. And a lot of times the seeing is excellent for days on end down in Florida and the Gulf and in the Keys. Another website I like to look at is called meteoblue.com. They have an astronomical seeing forecast. Again, this is all based on modeling and using thermal temperature data from weather balloons. You've got these different seeing indexes, which you're looking for is basically green across here. Jet stream, sorry, here. Jet stream is colored red here because this was taken when we were right under the jet stream. But essentially, you're looking for green here, and you're looking for these bad layers to be a very small gap between the layers. In this Kelvin per 100 meters, you want this to be very low flux in temperature to indicate that you've got good laminar temperature and good laminar airflow. And again, just a comparison contrast, Florida Keys. That's how I wish it looked. So just a couple things to try to maximize your viewing. Try to make your critical observations when objects are culminating. So obviously the higher the object that you're looking at in the sky, the better. You're looking through less atmosphere, so less opportunity to look through air that is of different temperature and different density. Early dusk, just after sunset. This is my favorite time to observe. The sun is just below the horizon. A lot of times the sky is still blue. There's like a sweet spot where you don't have the cooler air above descending so much, and you don't have the hot air below trying to blow up as much. There's kind of a sweet spot for a good half hour to an hour almost every night. I find where I can see, take for example, Saturn, the Cassini division will be etched, and then a couple hours later, it could be totally a flagpole, like what we looked at earlier. It can be a complete blob. And then the second best time is early morning, 3 a.m. to sunrise. But here in Michigan, more often than not, I find myself setting the alarm, going to bed, missing a nighttime observing, only to wake up to fog or clouds and being mad at myself for doing that. So the second thing is optimizing your equipment. It goes kind of without saying, but I try to look at the forecasted temperature when I'm going to be observing. If it's in the summertime, early summer, maybe the basement might be a little cooler than upstairs, or there might be a bedroom or a room where there's sun exposure where it's a little warmer. I try the best that I can to match my optical tube with the temperature that I'm going to observe and do critical observing. And I find that works really well. In the wintertime, if I have to, I'll just set the scope out 2-3 hours before I observe. And then insulation, the idea there is that if you put this Reflectix type barrier around your scope, it'll cut down on some of the radiative heating and cooling which cuts down on some of those internal tube currents. There are people on the cloudy nights observing boards that rave about and have said they've taken large aperture scopes or Maxudoffs, which are have a lot of mass and tend to cool slowly, wrap them in this reflectix, and they're saying they could take them out of the house with a 20-degree, 30-degree temperature differential and get a pretty good image. It slows down that rate of change within the optical tube. I haven't personally tried it yet. I've resorted to throwing a washcloth or a small towel on the top of the optical tube to try to slow down some of that supercooling effect. But my preference is to get the scope as close to ambient as possible. Choosing your observing site beside a large grassy field is best, preferably if it's upwind. Setting up on grass obviously cuts down on some of that radiation that comes off of hot pavement or sidewalk after dark. And if you have to set up on blacktop or concrete, one of the tricks imagers do is they'll hose it down late afternoon. That kind of cuts down on some of the heat buildup. Nearby houses, cars, buildings, you try to the extent that you can to keep them outside your line of view. If you have the option and you can set up, maybe move to the backyard somewhere where you're not looking directly over the neighbor's house. Takes a little bit of planning. And then the other thing is, if you have a small refractor and a big aperture scope, you don't have time to do thermal acclimation. Just resort to the small scope. Don't waste your time trying to get high performance out of a big scope that's not acclimated. And then as far as observatories, roll-off roof, superior because you can open everything up. The heat can radiate through the sky much quicker than slit observatory. And then lastly, I recommend keeping observing log. I like to keep track of what kind of seeing conditions I had and then what the temperature, wind, and weather conditions were, so that I kind of build up a personal history on when I'm most likely to get those excellent conditions of seeing. And it's just kind of a cheesy little graph I showed, but showing from the ground stratosphere on one axis, and then on the other axis represents your ability to control or how much money you're going to have to spend. Talking about jet stream, you're either going to have to move or go on vacation somewhere where you've got no jet stream. That's obviously kind of expensive and hard to control. Geological features, where you built your house, we talked about. You want to kind of stay on the windward side of large bodies of water. You want to stay away from the leeward side of mountains and large bodies of water. Nearby structures, move if you can. Set up to keep the neighbor's roof directly out from under the path of what you're looking at. Get your optical tube cooled down and set up on grass or on an elevated deck. So in closing, I call this seeing is believing, because when you can get the conditions right and you get your equipment right, amazing detail becomes available on planets. You can catch pinpoint stars, sub half arc second resolution, and even deep sky objects take on a whole new level of contrast, subtle contrast. Contrast transfer really improves with good seeing. You also can see what your optics are capable of delivering, and you can do good comparisons between telescopes when you've got excellent seeing. And visual astronomy is breathtaking when the conditions are right and you've got your equipment and you've done your homework. So that concludes my presentation.
All right, thank you, Mark. Always good to have an
I'm
observer
going to
talk.
unmute everybody.
Yeah, we have time for 2 questions before we take a break.
Any questions?
Well, actually, maybe just a quick comment. In the past, when we used to observe, one of the things that we used to ask people to do is, if you're out in the field, is to line up the telescopes from east to west, and you would be parked there with their car, or even setting up their telescope to the south of you, because looking at the planets, you're going to be looking mostly east to west and south. That's something that actually does work. And all it takes is for somebody to drive their car and park just south of you or where you're trying to look. Look above that, and you can see your image deteriorates directly above the vehicle. Depends on the wind too. And if you look left and right of that, actually your quality of the image will improve. So
that's an excellent observation and comment, Riyadh, because I'm guilty as charged myself. I like to park around the backside, and that's not a very good place to park when the ecliptic and objects culminate to the south there. And a lot of times I catch myself looking over open hatchbacks and open vehicles, and yeah, it's definitely not ideal. Very good point.
Yeah, we used to ask people also, like in the observatory, not to park their cars just south of the observatory because you can't move the dome, right? So
yeah,
that scope is stuck where it is.
Yep. One comment on the observatory. I've read people mention, and I think I talked to you about this, Riyadh, but logistically it would be hard to do. But if you set a fan up so that you're drawing air through the slit or through the dome, it's supposed to help a little bit, mitigate some of the turbulence that occurs above the building and into the building. You're drawing air through the building, through the dome. Be something worth experimenting with, but maybe for an members observing night or something, we could set a fan up at one of the doors.
We can try it and see if it helps one direction or the other. But that building, of course, has a lot of thermal mass. It's concrete, or cinder block, walls, and that absorbs the heat from the sun all day long and releases it all night long.
Yes, sir.
All right. Well,
Okay.
Thank you again. It's
Okay, thank you.
8:36, so let's take a 10-minute break. Feel free to chatter amongst yourselves, send messages back and forth, grab a drink or what have you. We'll reconvene at 8:45-ish for our feature presentation.
All right, Diane, I got some numbers for you. I'm seeing a swirly.
Numbers?
Yeah, so you mentioned that we're not seeing a transit of Venus because of the, particulars of the solar system.
Yeah.
And so it got me thinking what would need to be done to put Venus in the plane of the Earth.
Uh-huh.
And the answer I got after some quick Google searches for masses and speeds, you would have to hit it with the moon at the right time in the right direction, and the moon would have to be going about 17 kilometers per second.
Yeah, okay, well, having the
should-
moon keeps us alive, so yeah, I think I can dispense with that plan.
Well, and to put that number in perspective, it's about 17 times the speed that the moon goes around the Earth, and it's
Right.
about half the speed that the Earth goes around the sun. So moving the moon to that particular orbit would take just as much energy as moving Venus.
Huh.
So,
So Jeff, why don't we just move the Earth?
Jeffrey?
it's there are similar masses, and the Earth is going slower, so it would be easier to move the Earth. And the moon's closer, so all you have to do is hit the moon with the Earth at probably only like 15 kilometers per second, and
Jeffrey?
you could probably achieve the same thing.
Jeffrey, you need another hobby.
I've been telling people, when people say we don't have enough hours in the day, I say what we need to do is get the moon's orbit a little bit wider. Create some rotational drag on the Earth, and some people do. I hang out with a lot of geeks.
Jonathan, it is moving. Jonathan, it is moving away. So we just have to.
It is, but we need to accelerate the process. Is the thing. We need to burn some rotational energy.
Yeah.
I don't think anybody hanging out in an astronomy club chat room at 8:39 p.m. on a Monday needs to justify having geeks for friends.
That's for
Just,
sure.
just
That's
saying.
true. That's true.
Nicely put.
So you
I
want
wonder if you can.
the moon further away? You're good with annular eclipses only, right?
Okay, that is kind of a
Yeah.
drawback, but I mean, more hours in the day, you know?
That's
Yeah, but you can only get so many before you're going to lose the moon. But I'm curious if you could
That's true.
calculate
That is true.
at what point you get like 25 hours in the day. But I had talked to someone in the past, and they said like actually figuring out the interactions between the moon and tides is like not an exact science. So like
No, it's not.
they measure the speed of the moon's recession with the laser, but actually modeling it into the future apparently isn't a straightforward task.
Nope. So we have a comment from the YouTube video. RR says that he wishes that Gary Ross was hanging out. So Gary is hanging out on that couch there, but he's being uncharacteristically quiet. And RR also contributes that he, as a professional truck driver, he seeing on a daily basis on cars and on the road. So that's usually the example I give to people of what they're actually seeing when they see something moving around in the telescope. I say, you've seen a car on a hot day, or you've seen a patch of road that looks like it's wet even though it's not, and that is a similar effect. So
Can anybody hear me now?
yes, we can hear you fine.
Yes.
Oh, great. I finally fixed my microphone. Thank you.
Fabulous.
Great. So what did I? Oh, I wanted to bring up something. So the Great Lakes Stargaze is not canceled yet, but they have put out some advisories on it. They are not allowing advanced registration this year. It is going to be walk-in only registration to make it easier if they do have to cancel it. And if we do go ahead with it, September 17th through September 20th, they will not have a presentation tent. They will not have a door prize tent. They will have a hospitality tent, but that's about it. And it's also going to be entirely weather dependent. So if it looks like it's going to be cloudy, they're probably going to cancel the event. So it's basically they're hoping to have it, but it is going to be in a diminished state. So. And so far, Sirius Astro Products is the only registered on-site sponsor.
That sounds pretty depressing, to be perfectly honest.
Well,
well.
I mean, it's still a great observing site, and
It is.
If people aren't circulating as much as they typically do, I would still like to attend if it goes ahead. So I was wondering, has anyone observed from Alcona County besides Diane and me?
Sheboygan is as close as I've been.
John, is that up near Hillman?
Yeah, Hillman is in Alcona too.
Yeah, my very
Smurfs
first
was
star-
there, right?
What?
Smurfs was there, right?
Yes, that was my very first all-time star party, and it was amazingly dark in that area. Amazingly dark.
It's still pretty good. Connie! Oh my gosh, Jeff is juggling. Can we maximize that on YouTube? How many balls is that? I don't know if Jeff can even hear me.
Where is it?
I have to say, WebEx
All right, brother.
frequently crashes on me. Everybody's video just crashed out on me.
Doing good.
You are not alone. Same thing here, Jonathan.
Well, it might be our house connection then.
Yeah, actually, it's been very touchy here for me too. It just keeps kind of freezing and coming back, and I keep losing my own video.
I can see you guys.
Can they hear?
Let's see. Yes, we can see and hear you, and Cheryl too. Hi, Rosie. Wow, everybody is here. Although Rosie, we only see your arm.
Is Mandy noticing that?
Yeah, actually, she is.
Just like being at the dog park. Michael, I'm going to meet you here for a second.
Glad he's got another hobby.
So we actually got to 44 total attendees so far tonight. So that's a pretty good good showing.
Excellent.
Jim Shedlowski.
Good idea.
Jim Shedlowski has let me.
Mandy out. Mandy out.
Oh, I something that is somewhat treasury adjacent. I got a notification from Amazon that our Amazon Smile donation has been deposited. So that's about $17. We get 1% of people's purchases on Amazon when they choose us as their charity of choice. So
Nice.
Okay. So it is now time to reconvene for a future presentation. So settle in with your snack of choice, and I will let Dr. Dale Parton introduce tonight's featured speaker.
Thank you, Diane. Well, Dr. Alan Kaplan, we've got a lot of doctors tonight, seems like, has been a member of this club since 2002. And he's given presentations before on stellar evolution and globular clusters. He also gave a short presentation on the Curiosity rover, visited it just before it was put up into space and went to Mars. He reports that he's a retired pathologist. I wasn't sure what a pathologist was, so I asked him, and apparently he said a lot more than I can repeat, but apparently he spent a lot of time looking through a microscope at tissue samples and figuring out what was wrong. Very much layman's terms. If you see a telescope when you see him tonight, for a reason. So I thought he would be an excellent speaker to dig into the topic of space medicine, right? And I slightly twisted his arm back during our banquet last December, and he graciously agreed to research this topic for us. So, Alan, what did you find out? You're on.
Well, let's see if we can. Okay, I'm Alan Kaplan, and I'm going to talk a little bit about space medicine. And to get started, we'll just think about, well, Cheryl and I take a lot of driving trips, so we've been driving across the country a good bit of times. And while driving in a car or a covered wagon, if you want, across the country, you can take breaks. You can get out, walk around, stretch your legs, stop along the way to walk around a small town, have dinner at a local restaurant. That cannot happen when you travel in space. Imagine being inside that car or even an RV for days, like going to the moon, or weeks or months or even a year or two going to Mars, or even living on the space station for a long time. How would you respond to the rigors of travel off the planet you were born on and that our species evolved on? Hubertus Strughold was the first to coin the term space medicine in 1948. He was a former Nazi physician and physiologist who was brought to the U.S. after World War II as part of Operation Paperclip, along with others such as Werner von Braun. As director of the aeromedical research for the German Air Force, Dr. Strughold had been aware of the spaceflight ambitions of von Braun and others at the V2 program at Peenemünde. He had himself theorized for several decades on the medical implications of spaceflight. Strughold became the first professor of space medicine at the School of Aviation Medicine in the U.S. He was later made director of the Department of Space Medicine at the same institution, which is now known as the U.S. Air Force School of Aerospace Medicine at Brooks Air Force Base in Texas. After his death, Strughold, who played an important role in the production of the pressure suit worn by early American astronauts, was connected to war crimes committed in the Dachau concentration camp and stripped of most of the honors he acquired in his life. Though this may come as a shock to some people, spaceflight is dangerous. Your doctors will strongly advise against it. Riding a very, very complex machine that is loaded with huge amounts of high explosives is obviously very, very risky. O-rings and any of millions of other parts can fail and do. Things can blow up and do. Things can catch fire and do. The U.S. space program has had two major accidents, Columbia and Challenger, out of about 113 flights for a failure rate of 1.8%. There's also been other non-flight accidents. In 1967, 3 died in a fire on a ground test of an Apollo capsule. Commercial airlines have had a crash rate of 0.4 per 100,000 flights. This is a 4,500 times greater risk of going into space than flying across country in a commercial airplane. Even if you do manage to get up to orbit safely, you still have to return to Earth safely. Re-entering the atmosphere at 17,000 miles an hour is also a bit of a challenge. And while you are up there, you face other obvious hazards to your health, such as micrometeorites and orbital junk. Greater than 12,000 debris objects are up there that are larger than 10 centimeters, about the size of a softball. And they travel between 80 and 70 kilometers a second, which is about 18,000 to 250,000 miles an hour. These are being tracked from the ground. 900,000 objects larger than 1 centimeter are estimated to be up there. And many, many more satellites are going up very soon, thanks to Elon Musk and Starlink and OneWeb and others. Some European space agencies are beginning to develop new efforts into tracking these objects, and they're beginning to talk about ways to clean things up there. The temperature extremes are pretty considerable. Going from sunlight to shadow is about 500 degrees Fahrenheit difference. And of course, there's the vacuum of space. Suit penetration from a micrometeoroid strike or an inadvertent puncture from a tool or a wire or a sharp edge is a risk associated with spacewalks. The 14 layers of material that make up the spacesuit include a layer of Kevlar to reduce the probability of suit penetration. To date, there have been no recorded cases of suit penetration from micrometeoroids. However, a tear to the outermost layer of a spacesuit glove from a sharp edge was noted on STS-118 in August of 2007, and that resulted in early termination of the spacewalk. Spacecraft are pressurized to 14.7 psi, which is about 30 inches of mercury, 760 millimeters of mercury, which is normal sea level pressure. The transition from ambient pressure to vacuum during airlock depressurization can cause considerable decompression stress to spacewalking astronauts. Thus, before spacewalks, astronauts perform an oxygen pre-breathe protocol that reduces the level of nitrogen in the tissues. The astronauts are trained to recognize symptoms of decompression sickness, the bends. As a treatment for this, some protocols have been developed that involve repressurization, 100% oxygen therapy, and if necessary, overpressurization of the spacesuit by use of a bends treatment adapter. But beyond these obvious concerns, though, there's other less obvious issues. For example, even just the weightlessness causes many problems. Osteoporosis, bone loss, occurs if the weightlessness lasts long enough. You lose about 1 to 2% of bone density per month when weightless. On Earth, elderly men and women lose about 1 to 1.5% per year. Parathyroid hormones and vitamin D production are reduced, and thus calcium loss from the bones is increased by about 65%. This weakening of the bones can lead to fractures and breaks if severe enough. These can happen when we encounter gravity again, of course, but may occur while we're still floating around up there. Also, it appears that this bone density loss could take more than a year to reverse when back on Earth, but it may not get back to normal even then. Critical demineralization can occur after 2 years of weightlessness. Unless preventative measures are taken, the bone loss may prove to be the medically limiting factor for the duration of spaceflight. Most astronauts on long-duration missions to the ISS will fully recover their bone density within 3 years after flight. However, some astronauts will never regain pre-flight levels. Slide 10. Slide 10. Okay. Oh, I should have had that one there already. Okay. Muscle atrophy is another common problem that worsens with the duration of the weightlessness. This includes cardiac muscle. They currently sent some cardiac muscle up to the ISS to study in trying to figure out more about why the cardiac muscle is affected, or if there's something they can do about it. And that was just recent. Muscles lose both mass and strength during spaceflight. The muscles most affected are the postural muscles, the rhomboids, the latissimus dorsi, and the serratus muscles in the back, as well as others in the legs. After a 2-week spaceflight, muscle mass is diminished by up to 20%. On longer missions, 3 to 6 months, for example, a 30% muscle loss is noted. Muscle atrophy is due to a reduction in the size, not the number of muscle fibers. Protein synthesis in muscle fibers is decreased by 15%, and protein breakdown is increased. After just 3 weeks in space, the human calf muscles, the soleus and gastrocnemius, shrink by about 1/3. This noticeably affects slow twitch muscle fibers, which are needed for endurance. Muscle fiber cross-sectional areas are reduced by 20 to 30%. That's what pathologists want to see through the microscope. After about 4 months in space, muscle mass and strength seem to reach a new steady state. After returning to Earth, astronauts participate in an aggressive rehab program. They are temporarily restricted from participation in some activities, such as flying high-performance jets, because of the axial skeletal loading associated with high G-forces. Muscle mass and strength are generally back to normal after a few months on Earth. As a side note, since there will be some discussion about Mars next month, gravity on Mars is only 38% that of Earth's. So trying to treat this bone loss and muscle atrophy, they've used exercise bikes at first, but this caused too much vibration for some onboard experiments. So now it's treadmills with bungee cords and resistance machine workouts that have less vibration. These help, but do not fully prevent muscle atrophy. The astronauts on the ISS have to work out on these 2 to 3 hours every day to maintain some of the muscle strength being lost. This is a considerable loss of valuable time for the other things they need to do. A little side note, NASA has named a zero-gravity treadmill after Stephen Colbert, the comedian on late night television, because of his support of NASA via his humor. Other things that they are trying, biphosphonate medications can slow bone loss, and they do help somewhat for short-term weightlessness. There's also a compound called resveratrol, which is found in grape skins and therefore in red wine and blueberries. It has some anti-inflammatory and antioxidant and anti-diabetic effects. It's also been shown in It's also been shown in studies done at Harvard with rats to preserve bone and muscle mass. Though the resveratrol worked well in protecting the muscle, it was not a complete protection. And I was in the store the other day, and I happened to be walking through one section, and I saw that you can actually buy resveratrol now in stores. NASA is also looking at electrical stimulation and amino acid supplements to reverse some of these problems. Fluids, body fluids shift upward to the head and upper body when weightless. There's about a 10% loss of volume in the legs. These fluid redistributions are referred to as the puffy face bird leg syndrome. The fluid shift toward the head distends the baroreceptors of the central vasculature, which triggers suppression of the renin, angiotensin, and aldosterone hormone system. And this releases atrial natriuretic peptides that lead to increased renal excretion of salt and water, and there's thus a net reduction in plasma volume. In the first 24 hours of spaceflight, there's a 17% reduction in plasma volume that results in a transiently increased hematocrit, which is the percent of red cells in the whole blood by volume. This causes a decrease in erythropoietin, the hormone that increases production of red cells, which leads to a reduction in the mass of red cells. The net effect is an overall reduction of about 10% in total blood volume. I hope everybody's still with me.
I'm terrified.
You're terrified? Don't go into space.
I won't.
Okay, so you're still hearing me. Okay, good. This decrease in total blood volume leads to a lightheaded feeling on return of gravity. Redistribution of body fluids with pooling of blood back in the vasculature of the lower body combined with the reduced blood volume, contributes to landing day orthostatic stress, which means that they get lightheaded, they get heart palpitation and syncope. And typically 1 out of 4 syncope, passing out. Typically 1 out of 4 astronauts is unable to stand quietly for 10 minutes within hours of landing because of this. The increased calcium loss from the bones, combined with dehydration and decreased blood volume, increases the chance of developing kidney stones, particularly calcium phosphate stones. While 1 out of 10 people develop kidney stones on Earth, it's more common in astronauts. As of 2014, there were 14 NASA astronauts who developed them after their missions. In 1982, a Soviet cosmonaut was in terrible pain for 2 days. His crewmate could do nothing for him. They thought it was appendicitis. But before they could launch a rescue vehicle, the pain ended when he passed a small stone. Potassium citrate is sometimes used to help prevent the stone formation. And venous thrombosis. 11 astronauts were involved in a recently published study about the structure and function of the internal jugular vein. This was done in view of the sustained fluid shifts that we talked about earlier. The results of ultrasounds performed about 2 months into the mission revealed a left internal jugular vein thrombosis, a blood clot, in 1 astronaut. The space station pharmacy had about 20 vials containing a heparin-like blood thinner that they would use to treat this, but no anticoagulation reversal drug in case they gave too much. Injections pose their own challenges. Syringes are limited in quantity on the ISS, and drawing fluids from vials is a significant challenge in the weightless conditions because of surface tension effects inside the vials. So the astronaut began treatment with enoxaparin, which is the anticoagulant, initially at a higher dose that was reduced after 33 days to make it last long enough until an oral anticoagulant could arrive via a supply spacecraft. And anticoagulation reversing drugs were also sent. Although the size of the clot progressively shrank, spontaneous blood flow was still absent after 90 days of anticoagulation treatment. So he took these pills until 4 days before the return to Earth. On landing, an ultrasound showed the remaining clot had flattened to the vessel walls with no need for further anticoagulation. It was present 24 hours after landing and gone 10 days later. 6 months after returning to Earth, the astronaut remained asymptomatic. He had had no personal or family history of blood clots and had not experienced the headaches or florid complexion common in weightless conditions. Internal jugular venous thrombosis, like this, has most often been associated with cancer treatments and cancer, and a central venous catheter being used for various reasons, and of course IV drug abusers who inject their drugs directly into the internal jugular vein. So this study showed that they need more study, more research. All right. Well, also associated with weightlessness is space sickness, as opposed to seasickness. It's also called space adaptation syndrome, neurovestibular acclimation, and it's basically a disturbance of your sense of balance. Our inner ear gyroscopes need gravity to work properly. And on top of that, there's no up or down in space. There's just all the different directions. About 1/2 to 3/4 of astronauts suffer from this, ranging from just a queasy feeling to nonstop vomiting. In 1968, NASA launched Apollo 8. Astronaut Frank Borman suffered such a bad bout of space sickness on the way to the moon that Mission Control considered shortening the flight. Fortunately, just like people going to sea eventually get their sea legs, astronauts develop space legs within a few days to about 2 weeks. However, once they return to Earth, the opposite is true. Many of them have to work hard to get their Earth legs back again. Astronauts feel like the world is spinning whenever they move their heads for a while when gravity returns. This syndrome did not occur on the early orbital flights because the astronauts were strapped down. So treatments that they're trying for this are anti-nausea medications such as scopolamine, head restraints, head movement exercises, and various biofeedback training. Okay. Disturbance in proprioception. That's the sensing of the position of our extremities, our arms and legs, and being able to put your arm out and then touch your nose like the police do when they want to see if you're drunk. So proprioception doesn't work so well when you're weightless. I'll just leave that at that. So to treat these various problems that we've been talking about with weightlessness, of course, you can try artificial gravity. Rotating spaceships or space stations would solve or at least help with these problems. But things like that are very complex, difficult to design, difficult to build, and difficult to put into space. And oh yeah, they're therefore very expensive. NASA is working on a human-powered centrifuge, a bike that is pedaled around a 360-degree circular track. If you go fast enough, you can get pseudo-gravity to varying degrees. But the effect lasts only as long as you are pedaling, and it's stronger at your feet than at your head. Okay, so that's the weightlessness stuff. And now we can go on to another major issue. Radiation exposure increases the space traveler's risks of developing cancer, especially leukemias, and acute radiation syndrome. But it can also cause damage to the central nervous system, something called space brain, and other tissues. Okay, now we're going to get into a little bit of radiation stuff here. And I want everybody to study very closely because there will be an exam at the end of the talk. Radiation imparts energy to atoms in the body, causing electrons to be removed from various nucleic acids, proteins, and other compounds, resulting in breakage of molecular bonds and the formation of free radicals. The atoms or molecules lacking full complement of electrons and making them highly reactive. These free radicals then react with other molecules, turning them into other chemicals, basically messing them up big time. High radiation doses tend to kill cells, while low doses tend to damage them. Radiation exposure is measured in absorbed doses. The energy lost by the radiation and deposited in the body per unit of body mass. The unit is the gray, where 1 gray equals 1 joule per kilogram. And another form of that is 1 rad, which is 100 ergs of energy per gram of material. And 1 gray equals 100 rads. And you can see here on the chart, I won't read it all, but basically 20 micrograys is a chest x-ray. A 5-hour plane flight is 40 micrograys. 600 micrograys is a mammogram. And then 5 grays, which is 5 million micrograys, is the dose for an LD 5030, the chance of a 50% risk of killing a human in 30 days. But that's if it's given over a very short period. Different types of radiation have different qualities. The different density of ionization it produces per unit dose. Different radiation types are characterized by their linear energy transfer, the amount of energy lost per distance traveled. More energy left behind means more atoms ionized and more damage for the body to repair. It's this density of damage that makes deep space radiation, the cosmic rays, more dangerous than the ionizing radiation found on Earth. We'll get to that, back to that in a minute. Radiation exposure. The effective dose is the amount of radiation absorbed by a person adjusted to account for the type of radiation received and the effect on particular organs. The international unit is the sievert. The US unit is the rem. And 1 sievert equals 100 rems. So if you're in Atlanta 3 days, you get a background radiation of 1/100th of 1 millirem. If you're on 2 days in Denver, you get that same amount. If you're wearing a luminous watch for a year, you get that. If you fly coast to coast, you get that. And living next to a normally operating nuclear plant for a year, you get that dose of 1 millirem. Okay. Acute radiation syndrome, radiation sickness, radiation poisoning. It's an acute illness due to exposure of most of the body to high levels, usually about 0.7 grays or 70 rads, which is equal to 35 full body CAT scans or about 35,000 chest x-rays over a short period of time. The syndrome is due to depletion of stem cells in certain tissues. It's usually an external source and that penetrates to the internal organs. Symptoms are nausea, vomiting, diarrhea, and these can occur minutes to days after exposure. And you can also get infections and hemorrhage. It's very difficult to diagnose this without a history of exposure. Symptoms, time of onset of symptoms, duration of symptoms, and recovery time or time to death vary widely depending on the dose amount and type, and the exposure duration time and the organ system affected. Neutrons and protons generally produce the same effects as gamma, beta, or X-rays, but at lower doses. The radiation exposure to Scott Kelly, even on the ISS and low Earth orbit during his year up there, was more than 30 to 48 times that of a person on Earth, like his brother Mark. That's equivalent to about 10 chest X-rays every day. Okay, here you can see a lot of stuff comes from the sun, but then we've got cosmic rays coming from the galaxy. Most of the radiation in interplanetary space is from the solar wind, which produces a relatively constant flow of low energy radiation. While in low Earth orbit, the Earth's magnetic field provides considerable protection. The atmosphere also helps a little bit. For missions outside of the low Earth orbit, cosmic rays contribute a significant portion of the radiation dose. Cosmic rays ions originate from outside of our solar system, mainly from supernovas, and are mostly highly energetic protons and alpha particles, and a small component of other high energy nuclei moving at relativistic speeds. Away from the protection of Earth, the cosmic radiation is estimated to be about 1,000 times greater than on Earth. The highest energy cosmic rays measured yet have more than 10 to the 20th electron volts, the force of roughly equal to a baseball traveling at 100 miles an hour. In addition to cosmic rays, unpredictable and intermittent solar particle events can produce large plasma clouds containing highly energetic protons and some heavy ions that may cause a rapid surge in radiation both outside and within a spacecraft. And here's a chart that shows the major solar particle events as little red circles, and you can see that it kind of goes up and down with sunspot numbers. In 1859, a massive coronal mass ejection hit the Earth, and paper in telegraph offices caught fire. Aurorae were seen in Cuba and in Hawaii. This was called the Carrington event. In 1989, we had the Montreal event. a CME that burned out transformers from Chicago to Montreal. You hear that, Diane? Side note, as a side note, it appears that our magnetosphere is weakening. There's been a 15% drop in the last few decades that has been detected. A study from UC Irvine Department of Radiation Oncology, published in 2015, found that exposure to highly energetic charged particles, much like those found in the cosmic rays that bombard astronauts during extended space flights, cause significant damage to the central nervous system, resulting in cognitive impairments. This study used rodents subjected to oxidized oxygen and titanium. The radiation caused inflammation of the brain with reduction of the dendrites of the neurons and damage to the synapses. The damage caused decreased learning and memory. It's thought that these changes are not reversible. Similar changes can be found in cancer patients treated with high-dose radiation to the brain. People on the ISS do not suffer from this problem because they're protected from the higher doses of the cosmic rays by Earth's magnetosphere. Currently, NASA sets the radiation limit for astronauts at a 3% cancer fatality probability. Thanks a lot. They use a complicated formula based on age and gender. For a mission on the ISS, where proximity to Earth provides some protection from radiation, women can stay about 18 months and men can stay about 24 months before exceeding the limit. But on a mission to Mars, astronauts would be way over the limit. The European Space Agency limits astronauts to 1 sievert over their entire career. The Curiosity rover found that a single 860-day mission, round-trip mission to Mars would result in a 1 sievert exposure. During these 2 to 3 year missions, there's a good chance that at least 1 solar flare will occur, which could drastically increase their exposure to something like around 5 sieverts. Some astronauts have reported occasional flashing lights in their eyes, even when their eyes are closed, when in space. These may be cosmic rays hitting their optic nerves. So, as a treatment for this problem, as a response to this problem, you can stay near the Earth to be protected by the magnetosphere. I will point out that Mars does not have one. Oh, and the atmosphere on Mars is like much, much less than even 1% of ours. So it does virtually nothing to screen out radiation. However, there are some other things. Hydrogen is a good material to block high energy radiation, but it's explosive in its pure form. Think Hindenburg. Water has a lot of hydrogen, but it's quite heavy, and thus it's expensive to launch. Polyethylene, which has 1 carbon and 2 hydrogen atoms, is a lot lighter, and therefore it's a good choice. To completely block radiation, these hydrogen-rich materials would have to be about 2 meters thick, bulky and heavy. But about 30% is blocked by just about 6 centimeters. NASA is considering greater shielding, at least in sleeping areas. The European Space Agency is looking into lithium, which is another good element for that. NASA is also studying hydrogenated boron nitride nanotubes. I'll say that again. Hydrogenated boron nitride nanotubes, BNNTs. They're made of carbon, boron, and nitrogen with hydrogen in between the tubes. This is a good absorber of secondary neutrons and can be made into yarn. NASA is also looking into medications that may help. Vitamins A and C are antioxidants that can help somewhat. There is a drug called PLX 5622. It's used to protect memory and cognitive function in cancer patients receiving radiation to their brains. It is being studied for age-related memory problems as well. It protects the microglial cells from triggering inflammation in the brain. Astronauts in deep space may benefit from this too. Now, I'm told that there has been some very recent studies where that has helped. However, I will point out that testing on mice is not testing on humans, number one. Number two, just recently, there's been some new studies that have talked about memory and have shown that the memory in the brain is not just due to synapses, but is also due to shielding by with myelin around the nerve processes. And this is controlled by oligodendrocytes and astrocytes. Some put it on and some take it off. And they have been showing that the memory is related to the speed with which the signals go along the neurons, and the myelin insulation affects the speed of the signals. So there's a lot more to learn about this drug and other things to predict or to protect against space brain. Okay, so you can also travel faster, so you don't spend so much time out there.
I'm sorry, Alan. We're still seeing the sunspot graph. Is that?
Oh, yeah, that's still up yet. I'm not to the next slide yet. I'll get to that in a minute. So astronauts may benefit from this, but there's a lot more studying to be done. So you can also travel faster, so you spend less time out there. And another thing that NASA is looking into is electromagnetic shielding, basically a force field, I guess. And though they have that in Star Trek, they don't necessarily have a good one yet. An electromagnetic shield may help, but it would use a lot of power. And then what happens if something goes wrong with it, if it fails? So basically, at this point, damage by cosmic rays cannot be completely avoided. Now we'll go on. Effects on eyes. Nearly 30% of American space shuttle crew members have noted a loss of visual acuity after returning home from their 2-week missions, according to a 2013 report by the National Academy of Sciences. For the ISS astronauts who serve roughly 6-month orbital stints, the figure is 60%. Longer trips would likely mean an even higher percentage would be affected. In a study from the University of Texas Southwestern Medical Center, 8 volunteers with catheter systems and reservoirs in their heads for cancer treatments flew on NASA airplane flights that achieved 20-second periods of microgravity by repeated parabolic maneuvers. Researchers measured the volunteers' intracranial pressure during these weightless periods and compared those pressures with pressures observed while patients were sitting, standing, and lying down on Earth. The researchers found that intracranial pressure in microgravity, or in weightlessness, is higher than that while sitting or standing on Earth, but lower than that experienced while lying down. This makes intuitive sense. On Earth, gravity pulls blood and other body fluids down from the head toward the feet when people are standing or sitting, but not so much when they're lying down. The result suggests that the constancy of the intracranial pressure is what degrades astronauts' visions in space. It's called space flyers' eyes. They don't get the 16-hour break that ours get here on Earth as we go about our waking hours walking and sitting during the day. Astronauts are essentially supine at all times. So researchers are studying ways to give astronauts' eyes such a break. In previous experiments, they've shown that a vacuum-like device that fits over the lower body can lower intracranial pressures when applied for 20 minutes at a time. The plan is that astronauts would wear negative pressure clothing or some type of negative pressure device while they sleep, creating lower intracranial pressure for part of each 24-hour period. Okay, this is an ISS sleep station. Now, I'm not sure just how this picture actually goes, but the sleep compartments provide space for 4 people. The first person sleeps on the top bunk, the second on the lower bunk. A third person sleeps on the underside of the lower bunk, actually facing the floor. A fourth person sleeps vertically, attached to a wall with Velcro straps. Because the astronauts are in a weightless environment, mattresses are not needed. Instead, each bed consists of a padded board with a fireproof sleeping bag attached. Okay, now, this is an ISS toilet. I do not know how many they have on the space station, but let's just say that NASA has a lot of wonderful engineers and brilliant people working on getting people up into space and everything. However, their history with dealing with human body waste is something they don't talk about too much, for good reason. They have had a difficult learning curve on dealing with that. Things have gotten a lot better to get to this toilet. You have to strap yourself into the seat. It works by vacuum. Liquids are recycled and solids are sanitized. They get rid of the bacteria. They're dehydrated and compressed to return to Earth. I will not go into the rather unpleasant history of getting to this point with NASA. We will just move on to the next subject. Okay, so loss of a regular day. The sun rises and sets 16 times in 24 hours on the ISS, which orbits the Earth once every 90 minutes. Poor sleep is an issue. One study of 21 people on the space station showed they did not sleep well 29% of the time, roughly 2 months out of a 6-month mission. Probably related to stress and or the loss of a regular day in space. Also, the ISS is noisy. It's about 60 decibels. By the way, weightlessness does not prevent snoring. 3 out of 4 astronauts use sleep medications, which could be a problem if there was an emergency. NASA has been looking into using color-adjustable LED lights to deal with this. Blue aids sleep, but astronauts need to be able to tell colors apart, so blue can be bad at times. They're working on degrees of blue and other colors, and they're working to reduce the noise. Okay. Half of the Apollo astronauts reported bacterial or viral infections that occurred during flight or soon after return to Earth. Blood samples drawn from 9 astronauts after a flight on Skylab showed that lymphocyte activation was significantly reduced compared with that of pre-flight samples and samples from control people. Observations of astronauts' immune status after landing have shown numerous changes, including altered distribution of circulating leukocytes, the white cells, decreased activity of natural killer cells, decreased function of granulocytes, decreased activation of T cells, altered level of immunoglobulins, latent viral reactivation, viruses that are sitting around and doing nothing and then they can get reactivated, and altered virus-specific immunity. Rather important these days. In-flight and ground-based studies have shown that the lack of gravity impedes signaling pathways essential for early T-cell activation and leads to alterations in the organization of the cytoskeleton and the microtubules organizing centers in the cells and the leukocytes. This may be related to loss of circadian rhythms, lack of sleep, increased stress, or who knows. There seems to be a gradual improvement in these cells and these immunoglobulins and stuff a few weeks after landing. They're trying to have less stressful workloads and to maintain regular daily schedules. They're also trying light therapy, and gravity replacement might be good, but who knows. In response to COVID-19, the astronauts have been isolated longer before leaving the Earth and longer on returning to Earth. Other problems. Microorganisms. Space affects viruses and bacteria as well as humans. Microgravity has been shown to increase the virulence of such organisms, increasing microbial growth rates, antibiotic resistance, microbial invasion of host tissues, and genetic changes within the microbes, possibly due to the increased radiation. Urinary tract infections affect men in space far more than on Earth, according to one source, and they're greater in women, according to NASA. Hearing loss, some temporary and some smaller permanent losses are usually at higher frequencies, are occurring in astronauts. On the ISS, they had to wear earplugs all day, but NASA has been able to reduce the noise levels some with acoustic padding, quieter fans, and other methods. There's some suggestion, but it's not too well documented, about slower wound healing. Moon dust is very sharp-edged, very clingy. It can harm the lungs and the heart. It can cause irritation of the eyes and skin. It's been known to work its way through multiple layers of boots made of Kevlar. Diet and nutrition. Vitamins degrade over time and would lose potency over a 3-year trip to Mars and back. To grow vegetables in space, NASA has been studying have been studying various growth media and lighting combinations. They've been growing lettuce and just recently tasted some lettuce. Earlier lettuce growth was sent down to back down to Earth for studies, but they say that it tastes good, and when they've studied the lettuce grown in space, comparing it with lettuce grown on Earth, it's similar in nutrients, etc. So, and they've also been growing zinnias in space, I guess, to have some flowers around. One of the biggest challenges for growing stuff in space, though, is irrigation. Water behaves counterintuitively when weightless. It can easily leave roots dry, or it can drown them. Okay, a few other problems that astronauts deal with. Air pollution inside the spacesuits, the capsules, or the space stations is of concern because of possible entry of propellants, off-gassing from excessive off-gassing from plastics, leakage from various onboard systems or payloads, various microbes, and of course human metabolism. Situations are made much worse due to confined spaces and the recirculated air. Okay, this is two chest x-rays of an Apollo astronaut who was accidentally exposed to propellants during capsule descent. On the left, it's not a very good x-ray, or it may not be a good picture, but my personal radiologist says that it's probably very overexposed. But the idea is that the lungs are pretty clear. If you look on the right, that's where there's fluid infiltrates. Now, on the right side of the picture, where you can see the heart bulging, that's the left side of the x-ray, the left side of the astronaut. But you can see above the heart and towards the middle of the lung pretty easily, there's a bunch of infiltrates, little white areas. That's also seen in the upper portion on the opposite side and in the lower portion of the lung on the opposite side. We learned not to put pressure equalization valves too close to thrusters when the Apollo capsule became highly polluted with nitrogen tetroxide at the end of the Apollo-Soyuz test program about 45 years ago. When the capsule was descending through the atmosphere, thrusters started to fire in an attempt to stabilize the capsule, while at the same time, outside air was allowed in to increase the capsule pressure to sea level. Crew members experienced respiratory problems and release of fluid, into the lungs, like you see above. They were hospitalized for 6 days after landing and treated with oral steroids. No lasting effects were reported. Other examples. This is a freezer motor. A freezer motor frame overheated when the motor seized up. This caused release of formaldehyde and other nasty stuff. There are multiple other instances of similar events having occurred. The problems from these hazards are greatly magnified by the small enclosed environments the astronauts are living in and working in it all the time. And I can tell you, when I worked with formaldehyde, I had lots of fans going like crazy to suck the air away from me. And if the fan went off for some reason, I had to get out of Dodge pretty quick because it's nasty stuff. As a side note here, e-cigarettes, vaping, releases formaldehyde and other bad stuff when the propylene glycol gets overheated. Pulmonologists recommend smoking cigarettes rather than vaping because the cigarettes kill you slowly and the vaping will kill you faster. This is an oxygen generator from Mir. It also had some problems and stuff. So they're trying to have multiple layers of containment for some things. They're redesigning motors and they're using different materials to try to avoid these problems. Psychological and behavioral problems due to isolation and confinement. NASA has found that these are inevitable no matter the careful selection and training of participants. A Russian 17-month test led to problems with 4 of 6 people. On Skylab 4, astronauts got so testy with mission control that they turned off their radio and ignored NASA for a day. The problems include decline in mood, cognition, and morale. Monotony and boredom, lack of sleep, and overwork add to the stress. Meditation and pictures of nature are being investigated. Virtual reality might help. Gardening also appears to have a beneficial effect on astronauts' mood, as does the variety of foods they eat. The first doctor to be selected as an astronaut was Story Musgrave, a surgeon, in 1967. He flew 6 space shuttle missions from 83 to 96. And this is going to just show some of the different problems that astronauts have had. I think you can just skip that slide. They carry with them medicines to treat congestion of the upper respiratory tract, diarrhea, fever, and they've also had problems with with viral gastroenteritis, fiberglass irritations, and dermatitis. John, they've had dermatitis. And of course, inevitable space sickness and sleeping difficulties. The only onboard medical condition that was not treatable there was a case of transient arrhythmia during Apollo 15. And the medical kits they take on board are changed and upgraded every flight. Some things, however, are easier in space. This is Pete Conrad undergoing a dental exam by Joseph Kerwin, the medical officer. So that's nice to know. ISS astronauts have developed a way to perform CPR in zero gravity by bracing their legs on the ceiling while pushing down on the patient on the floor. Of course, current space medicine still relies on the possibility of returning home within a few hours. ISS is not equipped with facilities to conduct surgical operations in microgravity or with the most advanced diagnostic machines like those found in hospitals on Earth. Zero gravity, power requirements, and size put significant limits on the direct transfer of medical technology. However, they have been trying to miniaturize a lot of equipment. Some examples are, that can be used up there. Cardioversion paddles are devices fairly small and intelligent. They can determine if the patient needs to be defibrillated and then provide shock to the patient. They're fairly ubiquitous in the US and they can be used in space. Ultrasound machines are also compact and lightweight. One has been present on the ISS for years. In 2005, NASA had a project called ADUM, A-D-U-M, Advanced Ultrasound in Microgravity. headed by Dr. Dulchovsky, a surgeon at Henry Ford Hospital in Detroit. They were studying the use of ultrasound for medical diagnosis in space and expanded its use to bones and other areas of the body. They found that in some ways, ultrasound works better up there because the internal organs move around. The heart and liver move up in the body and closer together, so there's less distortion and clearer pictures. Images are instantaneous and transmitted to the ground where they are evaluated and diagnosed. The work has helped expand use on the ground too, on battlefields, for example. A similar setup has been used in the Red Wings locker room, where a trainer was trained to use the ultrasound machine. In space, even straightforward operations can be problematic, since bodily fluids and microgravity could easily contaminate the environment. In order to make possible surgical operations in space, researchers at Carnegie Mellon and at the University of Louisville have developed the aqueous immersion surgical system, which is a transparent box that creates a watertight seal when it's placed over a wound and pumped full of sterile saline. The saline is held under pressure inside the box to prevent blood from seeping out of the wound. Airtight holes allow the doctors to access the submerged wound using handheld instruments. The system can also be used to siphon and recycle blood by varying the pressure, which would be important for human space exploration, as it's unlikely that future missions will be able to carry a blood bank. Packed red cells have a shelf life of 42 days. Fresh frozen plasma is good for a year, as is cryoprecipitate. There's also work being done on remotely operated surgery robots, but I wouldn't count on that being likely anytime soon. And now we'll get to the last section here. Scott and Mark Kelly are identical twin NASA astronauts who were in a fascinating study a few years ago. Scott spent almost a year, 340 days, on the ISS while Mark stayed on Earth. A Russian astronaut, Mikhail Koronenko, was also up there with Scott for 340 days. A lot of data were collected on the two brothers over a 25-month period. 10 research teams were studying them. The majority of biological factors studied either remained stable or returned to normal within 6 months after returning to Earth. And here's some of the findings. Thousands of Scott's genes changed the way they turned on and off, likely showing adaptation to the new environment. A telomere is a region of repetitive nucleotide sequences at the end of a chromosome. It protects the end of the chromosome from deterioration or fusion with neighboring chromosomes. They normally shorten when cells divide, and they usually shorten more with stress. Cells die when their telomeres are gone. Telomeres on Scott's DNA, surprisingly, grew longer. Telomere extension has recently been found in certain types of brain tumors with both adults and children. They grew longer, possibly because of some stem cells, younger and therefore not having gone through as many divisions. They were released into the bloodstream. Many of these telomeres returned to normal within 6 months when back on Earth. But several months later, Scott had more short telomeres than before he left for the ISS. Because Scott was on the ISS traveling at over 17,000 miles an hour and his brother was on the ground, Scott aged about 1/100th of a second less than Mark due to relativity. That's according to Jeff's calculations, so don't blame me for that. Scott's body mass decreased in orbit. His folate level went up. Diversity of the gut bacteria did not change. The carotid artery wall thickened when he was in orbit. His fluids shifted to his head and upper body in space and involved the structural changes in the eyes we talked about. The immune response to vaccination did not change. So presumably if we get a vaccine to COVID, he'll be okay. And the most notable result, according to Scott Kelly, that after spending a year in space, he says, I am now not only smarter, but also better looking than my brother Mark. The end.
All right.
Presumably,
Fabulous, Alan. Who wants to go to space after listening to that?
Pardon?
Go to Mars.
I think Rebecca might be the best person to ask because she's the only one with the chance.
After spending a year in space, he says, I am now not only smarter, but also better looking than my brother Mark.
All right, who's watching on YouTube?
Jonathan mentioned your name exclamation.
Actually, I made it in the right time.
Yes, and since we don't have to clean up the snacks and drive to the Redcoat, we're in good shape. So, all right. Do we have any questions for Alan?
Yeah, how'd you fix the problem?
How did I fix the problem?
Yeah, you couldn't broadcast, you couldn't show the slides.
Jonathan told everybody to get off, and then we set it up, and then they got back on, and apparently it worked.
Wow.
Are you asking me to share my secrets, Victor? Because I have to keep some things to myself.
Sorry, Jonathan. I shouldn't have told him.
I'm involved in a lot of presentations, and if this ever happens to me when you're not around, I would like to come to the rescue as well.
Alan, with the debate coming up, I can't wait for the debate.
This is Dale. I can't wait either, and
I can't wait for the debate.
Yeah, you just
Dale, are you going to be
keen on that one?
Yes, we know what side Ken's on.
I loved it. Great job, Alan.
Ken?
Yep.
Yes.
Remember we discussed man in space years and years back?
Yes.
And you were saying we shouldn't go?
Uh-huh.
So now this talk was really for you, Ken.
I really appreciate it. You've always been a great friend, Alan. Hey, Bob, how'd you like that?
A lot of material there for the debate.
Oh my God. I was taking pictures of your screen like you can't imagine.
Oh boy.
I think I have a fairly good idea of how one side of the debate is going to play out.
My granddaughter Rebecca attended this talk, and she's texted me that she still wants to go to space.
She does?
Hey.
She does.
All right, Rebecca.
All I said is all problems are theoretical until they actually happen.
That's right. Yeah.
Okay. I'm good with that.
Cool.
Well, we'll figure out answers to some of them eventually, but probably, I don't know.
I already have seen most of them.
I think eventually is the big word. I don't think it's going to happen with Elon Musk in his lifetime, and I don't think it's going to happen for quite a long time. We need to have a lot of those issues dealt with.
And more.
Yeah, and then we don't know about other issues being out there for years in deep space.
I don't even mean medical issues.
Yeah.
Hey, Alan.
Yes?
First off, my math is always flawless. So
of course.
No special statements need to be said on my math. The flashing in the eyes.
Yes.
That astronauts see, I'm pretty sure that's strength off radiation. That it's not that something hits the optic nerve, but that it excites water molecules and you get strength off radiation. You see the blue flash.
What kind? Say that again.
Strength off radiation. It's a special effect that is seen in water. Well,
yeah. Oh, that's a thought. I didn't see that. When I was reading about it, they didn't mention that at all. They mentioned cosmic rays, but that's another thought. Yes.
Either way, it's telling you you're being exposed to radiation in your eye.
Yes.
I mean, I agree with Jeff about what's being seen. It's Cherenkov radiation, but it still means there's high energy relativistic particles going through your eye.
And the rest of you.
Yes, of course.
Going through everything. Yeah. And some of that high energy radiation, some of the cosmic rays, it's not just what's going directly through you, but it kicks off others when it goes through the space station walls and the machines and everything. So it's kicking off secondary radiation too.
Right. You're getting a cosmic ray shower.
Yes. Yes.
Sparkling clean.
Janelle?
Oh, he's asking about you.
Huh?
Janelle, you were saying? Hi. You wanted to hear that.
I just wanted to say that out of all the talks that I've listened to you guys do, you know, I probably have the least amount of astronomy background and understanding. And it was just great to finally, you know, I have a health science background to understand much more of a talk than Jeff did. Hi!
We have a comment in the chat from Catherine. With all the ways one's body can fall apart right on Earth, you might as well go to space and have a little fun for it. So,
well, that is an argument. That is an argument, but your body may fall apart a lot faster.
I think for some of us, the idea that space toilet is a deal breaker all in its own.
Well, I mean, it apparently does work, and this is a vast improvement over what was going on, like with Apollo and.
What's going on with Apollo? Yeah, I know that one. No, sir. Yeah. No way.
That was great.
All right.
All right. Thank you so much, Alan.
It was worth the wait. We'll
Yes.
fix that pause in post.
Alan,
Okay.
you did a
Thanks very
great
much
job.
to everybody.
Thank you, everybody.
Thank you.
Be safe.
Thank you.
We'll see you at Virtual Macomb.
Good, Alan. Yeah.
Bye.
All right. See you soon.
Great job, Alan.
Thank you.
Thank you.
Good night, everybody.
Good night.
Night.
All right.
Is it raining? It's raining.
The rain it raineth on the just and also on the unjust fellow, but chiefly on the just because the unjust steals the just's umbrella. Good night.
Good.